All right, let's talk about something that can be a real headache in Java, but also your secret weapon. I'm talking about exceptions.
You know that feeling, right? You're staring at this wall of red text in your console, a giant stack trace, and you're just thinking, what on earth just happened? For so many of us, exceptions just feel like random, frustrating noise.
But what if that noise isn't noise at all? What if it's actually a signal? In this explainer, we're going to flip the script. We're going to turn that confusion into clarity and make exceptions one of your best tools for building truly robust professional-grade software.
Okay, first things first. Before we can wrangle exceptions, we need a solid mental map of where they all come from. Getting this hierarchy right is absolutely key to understanding everything else.
It all starts here. At the very top of the family tree, you've got one class to rule them all, Throwable. Seriously, in Java, anything that can be thrown or caught has to, one way or another, be a descendant of this one class. It's the granddaddy of every single error and exception in the language.
So right away, Throwable splits into two very different branches, and this is super important. On one side, you've got error. Think of these as total system meltdowns, things like running out of memory. They're catastrophic failures that your app just can't recover from. Then, on the other side, you have exception. And these are the things your code can and often should be ready to handle.
You know what? To make this really stick, let's just forget the technical jargon for a second. Let's think about this with a super simple, real-world analogy.
And here it is. This makes it so clear. An error? That's a full-blown kitchen fire. The whole building is burning down. You don't write code to handle a fire, you evacuate. It's a system-level failure. But an exception? That's just running out of salt. Yeah, it's a problem, but it's a predictable, recoverable one. Your application can totally handle it. Send someone to the store and keep on cooking.
So digging a little deeper into that exception family, we find something called a checked exception. The cool thing here is the Java compiler is like your helpful but kind of nagging assistant. It literally forces you to deal with these potential problems. Think about reading a file. It might not be there, right? The compiler makes you plan for that possibility ahead of time. And then you've got unchecked exceptions. These are a whole different beast. Honestly, 99% of the time, these are just bugs. Your bugs. A null pointer exception, an argumental exception. The compiler doesn't make you catch them because the real solution isn't to write a catch block, it's to go back and fix your code so they don't happen in the first place. Okay, so now that we have our map, let's get our hands dirty. Let's look at the actual tools, the keywords you'll be using day in and day out to manage all of this. It really boils down to three key actions. You've got throws, which is like putting up a warning sign. You've got throw, which is the action of actually triggering an exception. And then you have the whole try-catch-finally block, which is your safety net and your cleanup crew all in one. So when you see throws at the end of a method, think of it as a contract, a promise. That method is telling everyone who uses it, hey, just so you know, I might run into this specific issue. If I do, I'm not going to handle it. It's on you, the caller, to deal with the fallout. The throw keyword, on the other hand, well, this is where you get to be in charge. Your code finds something that's just wrong. Maybe a user tries to create an account with an invalid email. You use throw to stop everything and say, nope, this is an invalid state. You're actively creating and launching that exception right then and there. Okay, we've got the concepts, we've got the tools. Now let's talk about what really separates the beginners from the pros. These are the practices that take your code from just working to being genuinely robust and production ready. All right, here are the non-negotiables. First up, never ever swallow exceptions silently. An empty catch block is a ticking time bomb. It hides problems. You've got to log it or rethrow it. Next, please use try with resources. It's the modern way to make sure your files and connections always get closed. No excuses. Also, be specific. Don't just catch the generic exception. That's like using a giant fishing net to catch a single goldfish. Catch only what you expect. And this is a big one. Use exception chaining. This is how you add context, turning a vague error into a super clear message. And finally, remember that exceptions are for, well, exceptional things. Don't use them for your regular program flow. It's slow and makes your code a nightmare to read. I really want to hammer this point home. Using try with resources, it's not just a nice to have anymore. It is the way to handle resources in modern Java. It prevents those sneaky resource leaks that can bring a server to its knees, and it does it all for you, safely and correctly every single time. All right, let's tackle one of the classic Java head-scratchers.
There's this trio of keywords that sound almost the same, but they mean completely different things. It trips up everyone at some point.
Yep, here it is. The question that has haunted a million job interviews and forum posts. What is the real difference between final, finally, and finalize? Let's clear this up for good. Okay, this slide breaks it down perfectly. Let's go through it. Final, that's a keyword. You use it to make something unchangeable, a constant, simple. Finally, that's a code block. It's the part of a try-catch that is guaranteed to run no matter what happens. Perfect for cleanup. And finalize, it's an old deprecated method from Java's past. The simple rule is just don't use it. Pretend it doesn't exist.
So what's the bottom line here? For cleaning up resources, the modern and safest choice is always try with resources. It uses the power of a finally block behind the scenes, but does all the hard work for you automatically and correctly. It's a no-brainer.
As we wrap this up, I want you to hold on to this idea, because it really changes everything. We started out thinking of exceptions as just annoying noise, but they're not. They are a language, a built-in, structured language for describing what can go wrong in our systems.
And when you get fluent in that language, when you learn to use exceptions to communicate exactly what went wrong and why, you're not just writing code that works anymore. You're engineering systems that are resilient, that are easier to debug, and that are truly professional.